Okay, hello everyone. Today we are going to look at more Linux commands. Okay, more Linux commands. This is the second class of Linux command. So we continue to learn more and more Linux commands under various different topics. For example, file system, network, security, and so on and so forth. Alright, so today is just general and widely used Linux command will be discussed. The platform that we are going to do today is not Raspberry Pi, but VPN. The command that you can do here also available on Raspberry Pi, because both Raspberry Pi and the VPN, the lab server, have the Linux running. The reason I am doing this is sometimes I work on a Raspberry Pi, sometimes I will come back to lab server. It's because for you to understand both cases. Alright, so today is the Linux server running on lab systems. To do that, you have to have a checkpoint secure remote, kind of lock shape once. So click, right click on that. Then there is a connected to. The IP is this, and then the password is that you already know, and then it's being connected. Alright, then you need to launch PuTTY, and then there is a let's see, yeah, 10.1.0.24 port number 2222. Okay, open it. Your login name that I mailed each of you already, so you can use that, and password also. Okay, when you get in, when I type last, then I can see who comes in. Not many of our students yet have logged in. Only those Montes, Thompson, Matthews, and Robinson. Those are the students once successfully logged in. Okay, so I want you to also log in here. Let's see. I want to settings, terminal, features. What I want to do, I want to, here, fonts, the size of fonts. Right now it's small, so I'm going to make it bigger, maybe 14, regular, apply. Alright, this is a little bigger, right? So you can do that. You can see it clearly. Okay. Alright, the first thing that we need to do is to see the history of the command that I issued on this server. Okay, so if you work on Raspberry Pi, then you can see also the list of the command history. So to see the command that you issued, the type history, then you can see all of those, right? So last one is the recent ones, right? Earlier one, so many others. On this lab server, it keeps so many, right? About 1,000, at least 400. I mean, I think almost 1,000 histories there. That's what we can do. The next one is to bang. Okay, so the recent few commands that we did, for example, history. If you do not want to type all history, then you can use a bang, exclamation mark, and H. Then the most recent past command begins with the H will be executed. In this case, like this, history, right? So okay, that's what I want to show. If you want to do, for example, ls and try to Python. Okay, by the way, where is, if we type where is Python, then it shows all the location where the Python name Python exists. If you type Python, then there is Python. If you do Python 2, then that runs. If you do Python 3, then so whole different command, right? Accordingly, different program runs, but I'm not sure this and that are the same or not. You know, to see that, we can do USR ls-l, so we can list the file information in long length. So Python, and then we can see this, right? So when I type Python, then by default it runs 2.7. When I type 2, then it runs 2.7. When I type Python 3, then it runs Python 3.5, and another mini version of a Python that runs. Okay, so when I do type Python, then it runs 2.7. So Python 3, then it runs Python 3.5.2, right? That's what Python 3. Then there is a symbolic link arrow sign. So this is nothing but Python 3.5, which is this. This much. This is the size of a Python 3.5, which is this, right? So I can quit that, clear, and then history and tail -20. Then I can see only the last 20 commands. Okay, so that's what it is. History, then it lists about 1,000 the commands that I recently issued. And then we have a pipe. So using pipe, the output of the first command will be the input to the next command. Next command is tail. Tail is the command very similar to more or head. The command head lists the first part of a file, whereas tail displays the end part of a file. So it shows last 20 of those. Here, if I use a bang, so if I do exclamation and P, then Python runs this. The past recent command that begins with the P is Python 3, right? Similarly, if I do L, then the recent past command that begins with L is ls. But if you see here ls minus L and ls, and then last, and a few of the command that begins with the L. If you want to do last, then you can type a little more, a few more characters, so that you do not execute ls, but la, whatever the command, the recent command begins with A. In this case, it gives that. Okay. And path. For example, when I use a bang ls minus L, then it runs. See, in the history, this is the last, and when I say ls, then this is the recent version, right? So it shows this. In this expression, the thing that I want to point to you is the path expression. To point a particular file called 2.7. File 2.7 is is pointed by this fully qualified path expression. Okay, fully qualified path expression begins with a slash and so on and so forth. In the homework assignments, I think homework 2, there I ask you to do, if you go to top of the system and type ls, there are so many directories available. So if you see the bin, something else, maybe etc, type etc, then there are also so many directories, right? There, if you type which one do you want to type? Maybe security, type security and ls, then you can see access.conf, group.conf, and then in some others, right? Namespace and limits, and so on and so forth. So if you want to see access conf, then you can see more conf. Okay, and let me press Q for quit that page by page content display. There's for more. If we want to display entire the content, then they use cat for concatenates. Then it shows all, right? The question here is that what is the path to come to this specific file? Then you can type pwd, so print working directory. This command displays the path expression to security in this case. Okay. So because security, let me see, what is it? Yeah, there's a security, and let me, yeah, I think if you type ls-l, then you can do cd limits. Okay, so pwd is this, and this also gives me, right? So these are the command that shows who you are, and okay. All right. So there's a path expression. And the grep. Let me go back to my home directory. Right now I am in etc security and limits.d particular inside the particular directory. But if I want to go back to my home directory, then simply cd and hit enter, then it brings me to my home, right? This is my home. Let me change directory 321 and ls. I have a few files already available. So grep tool searches for lines matching a specific patterns this command is good for searching inside files. So, for example, if you want to find grab Ubuntu from any text file. I have a few text files, txt, 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 many txt files, right? So by issuing this, grab is the command. This is the pattern that I want to search. And this is a file name, but not only one file, but I have star is a wildcard. So star.txt means any files with the extension txt, and then I hit enter. So actually there is a Linux, Ubuntu. Ubuntu can be found here, Kubuntu, which is in this Linux distributor.txt. Okay. Let's try to find the more maybe desktop. I want to grab the pattern desktop from all file with the extension txt. Hit enter. Binary file. Only this. Let's see some others. Try to find the system. I have more. So in this file, I have system here. In another file, I have a system here. Okay. So if we want to do, for example, create touch example.txt, and then I do echo, and then system, I'm going to give it to example.txt. Remember that we learned redirect. So echo is display whatever written after that, and then I have a redirect symbol. So output is not on your standard output, which is a terminal. So rather than on terminal, I want to put that on this file. So that is there. So make sure that I'm going to run grab system.txt to see if it finds that one also. See here, example.txt, it has a system, right? And then the other, as we did here upstairs. So grab is very, very useful. If you want to grab system from think I'm going to do grab with something else, something other. Oh yeah, here find. Find is another tool to search for files. Okay, this is going to search a file. So, for example, come back here. If I want to find from here to file name example.txt, see if it finds. Yes, it finds, right? Here. So I have a few examples in the following slide. File whose name is abc.txt, file whose name is abc.txt, but ignoring cases. So find the star name abc.txt to see if A and B. What I'm going to do, 321, I'm going to copy example.txt to example.txt. Okay, so I have a lowercase and uppercase of example and example. In the uppercase, I'm going to add one more. See here, the content of the example is simply system, right? But if I want to add more, for example, I'm going to put that on example. Double greater than sign is to append whatever the outcome of the previous command. The previous outcome of a previous command is to echo whatever it is, right? So it goes into the file here. So when I type example.txt, then I have what this lowercase example has plus something appended, right? With this, let's find from my local iname right. So when I do I, then it ignores the case sensitive. So I put here lowercase. So lowercase plus uppercase. If I don't do iname but simply name, then it returns the exact match lowercase of example, right? Directory whose name is derived. If we want to find the directory, then tab is D. Let's see what happens if we don't do anything but type D only. All the directories, right? So if I do 321, path must precede the expression 3. So maybe like this. 321 is there. Find type D for directory. Directory whose name is. Okay. Doesn't find. Let's see what happens if I do directory 321 from top slash. That's from top, right? Same thing. Path must precede the expression. Path. There's my path. If I express, I don't need to, right? So, for example, study. Okay, this is not working here. Okay, if you want to do an executable file or readable file, like here, that is a good tool for you to manage your Linux operating system, or if you want to hack into another operating systems, I mean Linux or Ubuntu operating systems to find out if there is anything executable, so that you may execute it as if you are a super user in the system, right? So sometimes you want to see how many or which are executable files. Okay, so let's find from my directory, and I'm going to do executable. Then they're all executable. Directory, if you change the directory, then that is executable. So that is the reason. And all shell files, they are all executable. So readable and permission. Each file has permit 0777. For example, ls-l, then my phone list. If you see phone list, okay, then ls in the result of ls-l, list of full list of the content, file information, right? So first column, which consists of 10 characters. First character tells you whether it is a directory or simply a file. And then after that, 3 characters bundled. Actually, there is no physical bundle, but I want you to imagine 3 characters together. Then you have 3 groups of characters. The groups appear, for example, a similar a word, right? A similar character, RWX, but sometimes there is a dash instead of something, right? So in this case, all dash dash dash. So what it means is that the first 3 character is a permission to me, which means this file, for this file, I can read, I can write, but I cannot execute it, because that file is not for execution, right? That's just text file. And next one is a group, permission to a group. In this case, my group is faculty, and this is me. I am in the group of faculty. So faculty can read, but no write, no execution. And the rest, all others, to the world, this file can be read, but nothing else, right? If it is a directory, for example, pick directory, then I can do read, write, and execute, and the faculty group can also read and execute, and all of others, anyone can read and execute. What do you mean by execute in this case? Actually, this is a directory. Directory is not executable file, isn't it? Yes or no? Yes and no, right? It's not really application program to be executed, but this, without execute it, we cannot change the directory to get into this inside this directory. So somehow there is execution involved. So if you say here X, so okay, you can execute for this directory. It means you can change the directory inside of that directory. Okay, if we prohibit this, then you cannot get into this pick. Okay, watch this. So when I do a CD PIC, then I can get in PIC, right? That is arbitrary ones, right? Back to. So there is a pick. If I want to remove the permission by chmod, ch for change, mode is that's for privilege mode. So chmod, and then if I want to extract X PIC, see here, pick does not have executable. X dash means it is not permitted. So I want to change pick. It says permission denied because I removed that one, right? So I need to change mode back in order to give the execution to everyone. Then I can do chmod plus X followed by that directory, and ls minus L. Remember that this PIC is only RW, RR, right? But now, after that, this PX is RWX, RX, and RX. So that type of things. So can I get some permission? Okay, by number. 7 means I can do anything, right? Read, write, whatever that. So let's try to find POM 0777. Oh, SS, this one ss.txt in directory 321 has that permission. 777, a number. 7 means if I have RWX, then that is the 7. So let's try to see. Back to 321 and check ss this ssx ss.text. See here, rwx and rwx and rwx. This means 777. Okay. All right. There is some find expression with the regular expression, but we will learn regular expression in a few weeks. Another thing is that okay, this is also very interesting to hackers, or interesting to the system manager to protect the systems. Find out the files according to the time, right? I want to find the last 50 days modified files. I want to find the files which may be modified in the past 50 days. Then you need to do this. Find, if you want to see it from top, slash, and then minus m times 50. So 50 less than 50 days. And more, because, well, let me just simply 50. A lot of them are permission denied, right? Okay, permission denied. See if there is not permission denied. But change the last within last 50 days. All permission denied. So I cannot get in. So what you can do here is that I want to find as a super user. For this, sudo find slash minus m time, and then let's put there 250 days. Okay, 250 days. The last maybe 9 months or 7 months or whatever. Okay, this is sudo command. If you are in this lab server, then you do not have sudo privileges. So for this, I wanted to practice on Raspberry Pi. As you install your Raspberry Pi, I know you set up your accounts. In that, you are automatically sudo list, so you can issue sudo find that once. Okay, so let's try do that, and but I want to do more command because this is a long list, and it asks me to enter my password because this guy wants to make sure that I am a sudo list and also proper password. I entered and hit enter. Some permission denied, but this is not denied, right? var library apt list security.ubuntu.com ubuntu that this file modified the last 250 days, and we may be able to see other files as well, right? Okay. And also you can find the files which were accessed the last 50 days, files which were modified the last 50 or 100 days, change files in the last 1 hours, change files, access files in the last 1 hour, so M time, A time, C time for change. All right. Okay, there's some exercise. Find all hidden files. How can you get the hidden files? Hidden file is something, for example, -LA, then you can see the hidden files. These are the hidden files, right? Something dot something, right? So find the for this, I think you need to have regular express. Let's see. It should be that and star, maybe. There are hidden files, right? So all hidden files comes up. Find all empty directories. Find all and remove all empty. I will let you do that. Okay, IO redirection. Remember that as you do execute, if it needs input, then the input comes from standard input, which is stdin. If it displays, then it goes to standard output. If there is some error, then there is also standard error, stderr. If you want to redirect that is possible. Standard input in computer, usually a keyboard. Standard output is a terminal, and standard error that generate error, but you can save it as a file if you want. So we did that, right? Greater than sign. Instead of displaying on your standard output, which is rather than on terminal, if you want to save it into a file, then you can do that. That's what we did many times. If you want to append double greater than sign, less than sign, that is a standard input. If you can combine greater than sign and less than sign, if you want to do input and then output, not from standard input and standard output, but designated from designated file to input, and also output to a designated file. That is also possible. Standard error, there is an ampersand, okay, greater than sign and ampersand. And also background job is possible if you want to do as a background. If you want to do background, then you need to put ampersand at the end, okay? So for example, Python 2 then there's a user interactive, so that you need to do something in there. But if you do ampersand, then it runs as a background. Let's see, this is stopped. So only one to some information about the job. So Python has been worked up to this, right? So you could do something else, but if you want to bring back that background job into foreground, then you can type FG, then it can bring up. Okay. Okay. If some job runs so long, then you can push into a background job. Meanwhile, you can continue to work your job or a simple job. So simultaneously, concurrently, your server handles two jobs together, one foreground and many in background. Okay, so that is what Ubuntu operating systems can do for you. Alright, I think this is it for today, and I will continue to do this next week. Alright, have a good day.